Hey guys, welcome to a new video in neural networks and deep learning tutorial. In this video here, we're going to talk about the Keras hyperparameter tuner. So we can actually use machine learning to actually train our neural networks. So Keras has a built-in module that we're already talked about. We have AutoKeras, but in this video here, we're going to talk about another module that is built on top of Keras to actually tune the hyperparameters when we are training neural networks. So we can find the different kind of learning rates. We can find the different kind of top layers in our neural networks, like how many neurons do we need to have in our top layer on top of convolutional neural network, for example. So we can use the Keras built on top of the Keras framework hyperparameter tuner. So that's what we're going to talk about in this video here. But first of all, remember to join the Discord server. I'll link to it down in the description here. And you're going to come join the Discord server and come chat with us about neural networks, deep learning, artificial intelligence, computer vision, and so on. And also, if you have some problems in your projects, you can ask your questions in there, or just come chat with us. You can now also be a member of the channel here if you hit the blue button under the video here, and you can support the channel with a small monthly fee that will just go to create more and better quality content here on the channel. So now we're not jumping to Google Colab here, where I'm going to show you how we can use this Keras AutoTuner to actually get the hyperparameters and to tune our actual neural network with machine learning. So we don't have to do anything when we're using this AutoTuner here for our hyperparameters. When we're creating neural networks, we just have a data set that we pass to these functions here with the AutoTuner, and it'll just figure out everything for us. It will find the best parameters for the best optimizer. It will use the best learning rate and also the number of neurons in the top layer on top of a convolutional neural network, for example. So we only need to pass in our data set, and we will then get the best neural network that fits best on that data that we pass to it. So first of all here, we're just going to import the modules as in all the other videos that we've been through here throughout this tutorial. So we're going to import Tensorflow here. We're going to import Keras because we're going to use Keras with this AutoTuner here, which is built on top of Keras. And then we're going to use NumPy, and then we're going to use matplotlib to actually plot the images and the results that we actually have from our dataset. Then we're going to set up the DPU here. So we use the DPU to train our neural network, convolutional neural network, as we've done in the previous videos as well. So I'll just run these blocks of code here, and to actually have this Keras AutoTuner here work, we first need to pip install it here in Google Colab, because this is not already pre-built into Google Colab. So we need to install the Keras tuner here. So we just make a pip install here in Colab, and then we just pip install this Keras tuner here, and then after we're pip installed it, we will just import this Keras AutoTuner here as KT, so we can then use it later on with this KT here to call the actual classes and methods inside of this Keras AutoTuner that will do everything for us when we're training our neural network. So I'll just pip install it here by running this block of code here. It'll do it for us, and then it will import it afterwards. Then we're going to set up the GPU here afterwards, so we can actually train our neural networks on the GPU. In this video here, we're going to load in the Fashion MNIST dataset. So we have these different kind of classes for our Fashion MNIST dataset. So this is the dataset that we're going to use for this tutorial here, and to be able to load it in, we actually have this dataset here built into Keras and Tensorflow. So we can actually just call this keras.datasets.fashionmnist, and then we can call this method here on this dataset here, or from this class here in Keras. We just call this function load data, and then we can actually just load in our data. We can store our images for our training data set in this variable, and we can also have a variable here for the labels in our training set, and we can do the exact same thing here for our test set here in Keras. If we run this function here, it will download the data set here from Tensorflow and Keras, and we will load it into these variables here so we can work with these later on. And then we're just going to pass these data sets here into our Keras AutoTuner, and it will take care of everything for us. Now we're just going to have this matplotlib function here where we can actually show some samples of our data set, so we can actually see what is in our data set, and then later on we're going to plot a number of samples of our test set, and then we can actually print out the predictions and see if our neural network is actually predicting the correct images. So we'll just run this block of code here as well, where we just have a function here to plot the images here in subplots. And if we just have this plot images here, and we take the first 10 samples of our training set, then we can actually see the images here that we have. So we both have an ankle boot here. We have some shirts. We have some dresses. We have some shirts, shoes, heels, and stuff like that. And then we can actually go down here and build the actual model from this Keras AutoTuner here. So we need to specify that we want to use a sequential model here, and then we also need to specify the input shape of our neural network. So the input shape to our convolutional neural network in this example here is 28 by 28, and these are just the dimensions of these Fashion MNIST images up here as we just showed here. Then we're going to go down here and actually like tune the number of units for our first dense layer. So we're going to have a dense layer on top of our feature extraction layers in our convolutional neural network. So then we actually like have these units here that we just pass to it here. So we have these HP units here, and this is the units for our hyperparameter tuner. So we specify that we minimum want 32 neurons, and the maximum value is 512 neurons in our first dense layer here. And we actually like want to pass this step here, so how many steps we actually like want to take when we're tuning this parameter here, or like the number of neurons that we want in our first dense layer. Then we just put this dense layer here inside of our neural network here, and at the end here we have 10 neurons here in our output layer of our neural network, because we have 10 classes, like 10 different classes in the Fashion MNIST dataset. So that's why we have these 10 neurons here, because then we get a probability of what class it has predicted of the Fashion MNIST dataset. Then we can also tune the learning rate here for the optimizer that we choose. So we can choose some different kind of learning rates here that we want to test throughout this optimization, or like this hyperparameter tuning. So in this case here, we set the learning rates for our hyperparameters here, where we just specify this HP here, which is the hyperparameter that we pass to our model builder function up here. And then we can have this method here inside of this hyperparameter here, which is called choice, and then we can specify that then we can choose that we want to specify the learning rate in this case here, and then we specify the values that we want to test for our learning rate with a specified optimizer when we're actually like tuning our hyperparameters in a neural network doing training. So we specify these 3 different kind of learning rates here that we want to train or like that we want to try out with this Atom optimizer here. So in this case here, when we compile our model, we actually like choose our optimizer here, and then we set our learning rate down here equal to this HP learning rate here. So we can actually like use both like this auto tuning here with Keras together with the actual Keras function. So this compile function here is from the Keras framework. So we can use them both together, and instead of just specifying like a certain or like a fixed learning rate here, we can actually like specify this HP learning rate here, which is just like a module or like a class here from the AutoTuner. So we can both use the AutoTuner together with Keras, which makes it really cool and really nice to play around with, because you don't need to change a lot of values from your original program if you wanted to specify the learning rate by yourself, or if you want to use this hyperparameter tuner. Then we also need to specify the loss function here that we're going to use. So we're going to use sparse categorical cross entropy, because we just want what class it actually like has predicted. So if you want to go more into details with neural networks, how they work, how with these different kind of like loss functions and optimizers, make sure to check the previous videos out in this tutorial here, where we go over everything from like the beginning and like how we can actually like create neural network from scratch, what the layer does, what the loss function does, and etc. And also how we can choose the best learning rate and stuff like that, and what happens when we're training on neural network. So make sure to check those tutorials out if you're interested in that. And here we're just going to specify that we want this metric here that we're going to specify, which is the accuracy that we want to track while we're training our neural network. And then at the end of the function here, we just return our model that we have created here with this model builder here, where we pass this HP parameter here to our function. So if I run this block of code here, we now have a function, so we can actually like build our model later on. Then we can instantiate or like initiate our tuner and perform the actual hyper tuning with these function here. So to be able to perform this auto tuning here, we need to have this tuner variable here, and then we just set that equal to the KT here, which is the module that we load in, so the Keras AutoTuner. And then we have this method here in the Keras AutoTuner, which is this hyperband here, or like this class here that we need to initiate. So we have this model builder function here, so at the actual function where we build our model every time we actually like want to create or like we want to try out a new architecture with different kind of layers or neurons in our neural network. And then we're going to look at the objective here, so we're going to look at the validation accuracy. So we want to have the highest validation accuracy as possible. We could also specify, for example, the validation loss if we want to have as low loss as possible when we're actually like going to perform this hyper tuning of our parameters. So the most optimal network will be the network with the highest validation accuracy in this case here, because this is the objective that we're going to track. We specify the max number of epochs that we want to train our neural network on. We also have this factor parameter here that we can specify here in this hyperband class. We can also specify the directory where we want to store the actual like logging. So this, when we're performing hyper tuning with this framework here built on top of Keras, then it will actually like log all of the data and all of the information from epoch to epoch, and per training step that we're actually like doing while we're doing this hyperparameter tuning with this framework here. So if you want to like go into the details and see the locking and what is going on like in epoch per epoch and stuff like that, it will lock all of that data to this my directory, or like the directory that you specify here for this variable, or like for this parameter here in this function or method. And then we're also just specify the project name here. So this is just an introduction to the Keras AutoTuner in this case here. So if I run this block of code here, we now have this tuner object here that we can then use later on to actually like train on neural network. Then we're going to specify a callback function here, which is stop early. So if our neural network is not improving anymore, and we're actually like going to look at the accuracy here instead. So we're actually like going to stop our neural network if it isn't improving when we're going to train it, and we have a patient here of 5. So if our neural network hasn't improved for 5 epochs, then we just terminate that training step and we just try out another architecture, or like another learning rate in this case here when we're performing hypertuning. So if we run this block here, we now have this stop early here that we can use as a callback function. And then we can actually go down here and start the auto tuning with this tuner.search here. So we're actually like searching for the most optimal neural network for this data set that we pass to this function. So we just pass the data set here that we have loaded in the MNIST Fashion dataset. So we have the image training data here, and we also have the labels for our training images as well. We specify the number of epochs that we want to run it through, and we want to split our data into like 20%. We want to use 20% of our training data as validation data, so we can actually like validate how good our model performs epoch per epoch when we're training on neural network. We specify the callback function here, stop early. So if our neural network isn't improving, we just stop that step and we search for a new optimal neural network with this tuner object here that we have created. Then we have the best hyperparameter. Like we get the most optimal hyperparameters here by calling this tuner.get best hyperparameters, and then we set the number of trials here equal to 1, and then we just take the 0th index of that, so we can actually like store all of the best or like the most optimal hyperparameters in this variable here, and then we can just print it out afterwards, so we can actually like see what is the best hyperparameters for this neural network after it has found the most optimal neural network. So if we run this block of code here, it would like to like search for the most optimal neural network. We get some of these values here that we can see like while it's actually like training, so we can see the hyperparameters. We have some values here. We have the best values so far. So right now it hasn't trained for that long, so we haven't gotten any like best values so far. But now we can see it has been going through the first epoch here. So we can see that we have a value here in this case that we're trying out now. So we're running trial 3 in this case here. And we can see the number of units here, or the number of neurons that we have in our first dense layer as we want to test as well. And then we can see the best values so far over here. So these values here updates all the time. So these values here are network that it is like searching for or like testing on right now. And then the best values over here is the actual like best values for or like the most optimal hyperparameters for all the neural network that it has been searching through here in this training step. So it's now done finding the most optimal hyperparameters for this dataset here that we just gave it to the fit function. So in this example here, we get the best validation accuracy so far. So the neural network that performed the best had a validation accuracy of 0.85, and it took around 8 minutes to search through all of these different kind of trials here, try to tune the learning rate and also the number of neurons that we have in our first densely connected layer. So it took around 8 minutes to find the best hyperparameters for this data set here. And then down here, we just print out that the hyperparameter search is complete. The optimal number of units in the first densely connected layer is 384, and the optimal learning rate for the atom optimizer that we chose is 0.0001. And now we actually like have the best hyperparameters, and we can then go down and build a new neural network with those hyperparameters, train it again for a number of epochs, and then we actually like get the best neural network because we're using the best like the hyperparameters that we found with this AutoTuner. So if we go down here and train the actual model here, we just have this model variable as we already always have when we're training all neural networks. And then we have this tuner here, our hypermodel.build. So we have this method here that can actually like build this hypermodel here from the tuner class. And then we just specify this this best 8PS here, which is the hyperparameters. So we pass in the best hyperparameters that we just got from the code block up above. And then we then have a model here with the best hyperparameters, and then we can just use that model to actually like train it again for a number of epochs. So in this example here, we're just going to train it for 30 epochs. Again, we're passing in our training data set, so we have our images for our training data and the labels for those images as well. And we're going to use the validation split of 0.2 in this training loop here again. So if we run this blob of code here, we will now train the neural network again for 30 epochs here with the best hyperparameters that we found from the code up above. So our neural network is now done training here, and we can see that our accuracy for both the validation set and our training set is actually like both going up, and the loss is actually like decreasing epoch per epoch. So we can see down here at the bottom, we end up with a loss here on our training data of 0.18 and an accuracy of 93. And we actually have a validation loss here of 0.78, so we have a fairly high validation loss. But when we did the hyperparameter tuning, we only wanted to like look at the validation accuracy. So we end up with a validation accuracy of 0.87 in this case here. So if we just go down here and plot the actual like data for our training loop, then we can actually like see here that our validation validation accuracy here is actually increasing, but we're overfitting a bit here at the end after like around like 3 or 4 epochs. We actually like have a bit of overfitting in our neural network, but we can see our training data here is actually like fairly nice, improving over the epochs. So this is just like how we can plot the actual data for our training loop when we're training our neural network. So if we go down here and evaluate the model that we have just trained, then we can actually like go down here and have this create this evaluation here. We're going to have this model here, so the model that we just trained. So we now have all the different kind of parameters for that model here in this object here. And then we can actually like just call the evaluate function here, and we want to evaluate our model on our test set. So we both got a training set and a test set when we actually like load in our data from the MNIST dataset. So we just specify the image test labels, images here, and the labels for those images as well. And then we can just print out the evaluation here down here. So if we run this blob of code here, it will just pass all of the images in our test set through our neural network and then see how good it performs. So to the left there, we can see that we get the test loss and the test accuracy. So we kind of get the same accuracy and loss as we did with our validation data. So that is pretty good. So we can both like, so we can actually like do predictions on data that our neural network hasn't trained on before. So if we go down here at the end here and actually like do predictions with our neural network, so we can see what is it predicting when we're passing an image through our neural network, then we're just going to plot the first 10 images here in our test set. So we can see that we both have like a booth here, we have like a shirt, we have some trousers and stuff like that. And then if we go down here and actually like do the predictions here, then we can actually like see what we are predicting. So if we want to look at the classes here, we can see that in the first image here, we actually like predict a 9. So a 9 corresponds to an angle boot in the Fashion MNIST dataset here. So we can see that is the correct prediction. So this is an angle boot. And then we predict the second image here to be class 2. And the class 2 here is actually like a pullover. So this is a correct prediction as well. We can see that we can now get 2 1s here, and the 2 1s here corresponds to trousers. We have the 6 here, which is a shirt, so that is correct as well. And then here we predict a 1 again because we have trousers. And then at the end here we have a 4 and we have a 6. So the 4 is a coat, and the 6 here is a shirt again. And then we can actually like predict here, we have a 5 and a 7 here at the end. And the 5 corresponds to a sandal, and the last one here, which is a 7, corresponds to a sneaker. So we can see that we're actually like predicting really high accuracy, and we can actually like predict all of these 10 images here because we have a validation accuracy of almost like a 90% accuracy. So we can actually like do predictions with our neural network. We can pass in images that it hasn't seen before from this Fashion MNIST dataset, and then we can actually like predict what class is in these images here, like for example angle boot, shirt, trousers, like different kind of shoes and stuff like that. And we can actually like see a difference between like this shirt here and the other one over here. So it could actually like find the difference between those, and it also found and predicted that this one here was a pullover and not just a shirt as in this example here. So it's a really nice and accurate neural network here that we actually like just trained by passing in the data set to this Keras AutoTuner here, and then it took care of everything by itself. And now we can actually like do predictions with our neural network where we haven't done anything. We just passed in our neural network. We got the most optimal hyperparameters. We passed those parameters into our neural network. We built that network, and then we actually like train our neural network again for a number of epochs, and then we can actually like now do predictions on these test images here and see that we actually like predict really correctly. So thank you guys for watching this video here, and remember to hit the subscribe button and bell notification under the video here, and also like this video here if you like the content and want more in the future, because it'll help me and the YouTube channel out in a massive way. I'm currently also doing a computer vision tutorial where we're doing some different kind of like computer vision operations, camera calibration, stereo vision, and a lot of different kind of cool projects. So if you're interested in that tutorial, I'll link to it up here, and we're going to combine that with deep learning later on. So I'll see you in the next video, guys. Bye for now.